And what we're going to learn about today is what does a negative do to a graph? And you've seen that a little bit already, because remember you had an x squared graph? What did a negative x squared graph do? It flipped it down. So you've seen that flipping. One of the flipping we never did with a parabola was flip it vertically, because it actually doesn't make a difference, right? If you have it and flip it, it's like, oh, I got the same parabola. So it never really came up with parabolas flipping something, or sorry, horizontally over the y-axis. We mainly did with parabolas flipping something down. And we never flipped anything with lines because we just learned how slopes work. But the pattern that happens with all graphs is that if you have a negative outside the function, and we're starting to see that outside with adding and subtracting, that move things up and down, outside with negatives is going to flip things vertically. So we're starting to talk about expanding our idea of outside of the function and inside of the function. Outside of the function will always affect things vertically, will always affect the y values. So if I had this point 8, 4, and I had a negative outside of the function, that would flip it, and it would take that point 8, 4, and now you would have 8, negative 4. Only thing that would be affected would be the y coordinate. Similarly, we're going to find out that if you have a negative on the inside of your function, so notice that this negative is with the x, everything inside the function affects your x values. Everything inside of your function is going to do something horizontal, and so this will be a horizontal reflection, or a reflection over the y-axis. So if I had that original red graph, now it would get flipped over here, and this point, 8, 4, would now be at negative 8, 4, and it's a complete reflection over the y-axis. So in the space that you have beside this shaded box, I would like you to write down the following notes. So the first one is if you have a negative on the outside of the function, sometimes they'll show that negative on the outside like they did here, and sometimes they'll multiply both sides by a negative and actually have the negative on the side with the y. We generally like to write the negative in front of the function like this, and this is the instruction. So if that negative is outside the function, technically that means it could be with the y. Then this is a vertical reflection. A vertical reflection means that you will flip something over the x-axis. Algebraically, what's going to happen, and as we saw from the red graph to the blue graph, the y values are going to get multiplied by -1.
The interruption, last call, grade 10 students, French immersion students to the theater, please. English students to the gym, that's grade 10 students, last call.
And then after this, we'll also write some notes on the negative on the inside of the function. So if the negative is inside the function, in other words, that negative is with the x value, that would be a horizontal reflection. Just like we saw above with the reflection of the red graph to the green graph. Oh, I can't remember the color. it would be a reflection over the y-axis. And algebraically, now your x-coordinate is going to get multiplied by a -1. So we have two places for the negative, either inside the function or outside the function. Everything inside affects x, everything outside affects y. We usually think of things that are affecting y as vertical changes. So if you think about that negative outside, you imagine flipping something vertically. If you see that negative on the inside, you imagine flipping something horizontally. Now, when you flip something vertically, it's going to flip over the x-axis. So sometimes that can cause confusion because you're thinking y values, but you're flipping over the x-axis. But imagine if you had a single point, and if I go straight down, if I flip down, does it make sense that the x is not changing? The x-coordinate would still be the same, and it's the y that's changing. So if you imagine, if you ask yourself, okay, if I flip something horizontally over the y-axis, which coordinate is changing? My x-coordinate or my y-coordinate? And if it's my x-coordinate that's changing, that means that negative was inside the function with the x. So now we can look at example 1. Here's the graph of g of x. Again, just some random graph. We could also get questions with any of the 4 graphs that we had on our colored paper to begin with. Sketch the image after a reflection in the y-axis. State the domain and range of each function. Okay? Now, what I'd like you to do is underline reflection in the y-axis, and above that, okay, so reflection in the y-axis is a horizontal reflection. In function notation, that would be a negative with the x because it's horizontal. And I'm also going to write over the line y equals 0. And the reason I'm writing all 4 of these things is I've seen on final exams, on provincial exams, on quizzes, that the same question gets asked with any one of those 4 things. I could ask you to reflect over the y-axis. I could ask you to draw the transformation y equals f of negative x. I could ask you for a horizontal reflection. I could ask you to reflect over the line x equals 0. There are 4 different wordings for the same thing, okay? If you come into a test or a quiz and you see new wording, that often is a case where students will be like, I don't know how to do this, and it makes you nervous. So what I try to do is I try to help you by showing these are all the different ways of saying the same thing. And once we get used to that, then we're able to do the question better. In fact, it's not a bad thing when you do a question to say, oh, you're right, reflection over the y-axis. What kind of reflection is that? That's a horizontal reflection. What does that look like in function notation? There would be a negative with the x. And if you think about those things each time you do a question, it helps you prepare you for when a different form is on a test. So we are taking this point, I'm going to graph it in blue. A reflection in the y-axis. Well, over the y-axis means your x values are changing, so this point here is going to get reflected over there, this point over to there, this one over here, and finally this point 5 away, over there. If we took one of these points, for example, this is at 5, 2, sometimes you, like this one, I just counted things out, but mathematically on this one, can you see that all that's happened is your x coordinates have gotten multiplied by a negative. So that 5, 2 becomes negative 5, 2. This one, we do one more, this point here, which was at negative 3, 1, is now at positive 3, 1. So all that's happening is your x values are getting multiplied by negative. We can do a little bit of connect the dot right now, always fun, and draw the graph. Can you see that the red one was flipped over? Sort of like that to match up with the blue. Now we have to do the domain and range of each function, so I'll do the red one first. Like I said, as we get going now, I'm going to start switching between interval notation and set notation. This time I'm going to do both the domain and range in interval notation. For the domain, we always start with, is there a smallest x value for the red graph? Yes, minus 3. Minus 3 is included, so we use a square bracket. Is there a biggest x value? Yes, positive 5. That would be my domain. For my range, the smallest y value, negative 2, and a biggest y value, positive 2. For the blue graph, is there a smallest x value now? The smallest x value is minus 5, and the biggest x value is positive 3. And for the range, smallest x value is negative 2. The biggest smallest y value is negative 2. The biggest y value is positive 2. Do you notice that those are the same? That should make sense, because what's the only thing we did is we changed our x values by multiplying our x values by negative 1. We didn't do anything to our y values, so it should make sense that our range, which is measuring what our y values are, stayed the same. Do you notice the pattern that happened with the domain? Can you see that it got multiplied by a negative 1? The negative 3, which used to be the smallest value, became positive 3, which is now the biggest value. And the 5, which was the biggest value, got multiplied by a negative 1, and is now negative 5, the smallest value. So we can see patterns that are happening in the domain and range. Okay, circle questions 3 and 13, write them down and circle questions 3 and 13.